Today we're going to look at energy in a collision. It's the last lesson in our unit on momentum and impulse. We'll take a look at a couple different examples and then you'll be able to finish up your formative assignment. Please be prepared for your quiz coming up as well as your unit exam following that. You can ignore the Smart Notebook limited mode in the bottom right corner. It's just because I'm doing it at home and I don't have the full version of Smart Notebook like I do at school. So let's just take a look through our objectives here. You will be able to classify energy as scalar, so that makes sense because energy does not have direction. Should we already be able to do that? And then you will be able to define elastic collision and inelastic collision. Calculate that should say the kinetic energy, which is equal to 1/2 mv squared. Calculate the initial energy, calculate the final energy. So this symbol here, we haven't had a chance to talk about it. Kind of looks like an E, but not quite. That means sum of. So when we're talking about that symbol, we're talking about the sum of the kinetic energy. And here we're talking about the sum of the final energy. So it just means all of the energy at the end is added up. And then it says use kinetic energy to classify collisions as either elastic or inelastic and relate SI units to physics quantities. And then there's some standard of excellences here. Solve for any variable using the concept that an elastic collision is where your kinetic energy at your initial kinetic energy is equal to your final kinetic energy. Explain what has happened in terms of the work done by non-conservative forces to kinetic energy in an elastic collision. And lastly, compare and contrast the conservation of momentum and kinetic energy during any collision. So let's think back to what we have learned so far when it comes to the momentum of a system. The momentum of a system, when we're talking about isolated systems, all right, it's a little bit harder for me to write on my computer, so you'll have to bear with me. So when we're talking about isolated systems, we can always say that the momentum at the beginning is going to be equal to the momentum at the end. That is, the momentum is conserved. So we could even break that down a little bit further. The momentum of object 1 plus the momentum of object 2 is going to be equal to the momentum of object 1 prime, that is after, plus the momentum of object 2 after the collision. So the momentum is conserved. That is also true about energy. Your total energy at the beginning is equal to your total energy at the end, signified there by prime. This includes friction, as well as any energy that might be lost to sound, or maybe light energy. So it doesn't even have to be in an isolated system for the energy to be conserved. That being said, the kinetic energy of the system may be conserved or may not be conserved. So if it is not conserved, all that means is that it has been converted to some other type of energy. So maybe it's been lost to friction, maybe some of it even to sound. We have two different options to look at here. So there's two possible situations. So we're going to look at what happens if it is conserved and what happens if it isn't conserved. So the first situation would say that it is conserved. So from that, we can say, here's that symbol again, the sum of your kinetic energy initial is equal to your kinetic energy at the end. So your EKF, which is your kinetic energy at the end. So this means that the kinetic energy is conserved, and we call this an elastic collision. So that's the first situation. And then the second situation would be that your EKI is going to be greater than the sum of your EKF. And now what that means is that your kinetic energy hasn't been conserved and you've lost it to some other form of energy, and we call this an inelastic collision. So you've probably seen this on your assignment already. Lots of questions asking, is this an inelastic collision? Or is it an elastic collision? So I'm going to show you in 1 second how to calculate that. And then just remember here, I'll put it down here, what this sum symbol means. So EKF, for example, would mean the sum of your kinetic energy for your first object at the end plus the sum of your second object's kinetic energy. So this changes depending on your situation. Maybe it's a collide and stick where you only have one object moving at the end because they've combined, but you have to take into account all of the things that are in the after situation. So let's take a look at an example. This includes both outcomes from last lesson as well as energy in a collision, the one we're looking at now. So it says a 1,200 kilogram car traveling at a velocity of 10 meters per second west on an icy road collides with a 15 kilogram stationary truck. Determine the resulting speed if they interlock. So remember, this is where you're going to break it into what's happening before and what's happening after. Notice here that this is what we call a collide and stick. So after, we know that we're going to have M1 plus 2 because they join forces, and V1 plus 2. And in this case, V1 plus 2, that is what we are trying to find. So M1 plus 2, in this case, that's going to be 2,700. So make sure you have your calculator handy so that you can be plugging things into your calculator as we go along. I'll be doing the same thing. Let's look at what's happening before. So let's state that M1 is the car. It's going to be 1,200 kilograms. And it is traveling at a velocity of 10 meters per second west. And then we also have a stationary truck. So M2 is 1500. And V2 is 0, which means that this object has no momentum before. It is only going to have momentum afterwards. So notice here that we're only dealing with west, and we don't have to even consider the y components. That makes our life a lot more easy. So in all situations, we know that the momentum before is going to be equal to our momentum after. And then we just have to consider what is happening before. So the only momentum we have before in this situation is our first vehicle. So M1, V1. And the only momentum that we have after is the objects traveling together. So that's going to be M1 plus 2 times V1 plus 2. And I forgot to put a prime up here, so let's add that in. And then we are solving for V1 plus 2. So I'm going to divide both sides by M1 plus 2 to find my velocity. All right, sub in, we have 1200 kilograms times 10 meters per second divided by 2700 kilograms. Okay, type that into your calculator. Okay, so the answer is V1 plus 2 prime is equal to 4.44 meters per second in the west direction. All right, so now we can move on to part B. This is our new outcome. It says compare the kinetic energy of the vehicles before and after the collision. All right, let's hope it's not going to jump. There we go. Okay, so before and after the collision. So let's do before first. So remember, we are looking for the sum of all the kinetic energy initial. In this case, the only thing that has kinetic energy at the beginning was our, I believe it was a car. So the truck did not have any kinetic energy, so I don't need to include it in the sum. So in this case, the sum is only going to be 1/2 m1 v1 squared. So we do not need to include the mass of the second car. So that'll be 1/2 the mass of the car was 1200. And the velocity of the car initially was 10 meters per second. And square that. Okay, go ahead and type that into your calculator. And that gives you 60,000 joules. So we have now found the kinetic energy before. Now let's find the kinetic energy after. So it's the sum of the kinetic energy at the end. In this case, since it was a collide and stick, it's going to be 1/2 times m1 plus 2 times the velocity that we found. So 1/2 m1 plus 2 is 2,700, I think. Yep. And then v1 plus 2 we found to be 4.444. I'm going to leave a couple more sig digs here just to make sure we don't round too early, and then square it. So type that into your calculator. And we get 26,667 joules. So our before does not equal our after. That automatically means that it is not an elastic collision. So since the sum of EKI is greater than the sum of EKF, therefore it's an inelastic collision. So if they are not exactly equal, then that means that it is not going to be an elastic collision. It is inelastic, which means that some energy has been lost to something other than movement, whether that might be friction or sound or light. It's been lost. All right, let's move on. Example number 2 says determine if the linear collisions from example 4 and 5 are elastic or inelastic. So we're talking back from our previous lesson. So let's go ahead and try and find that for a second here. Oh, that's not what I meant to do. All right, we're going to change it and do example 4 and 5 from linear momentum first. So flip back to example 4 and we'll get some data. So we had a ball moving 6 meters per second right, collides with a 2-kilogram ball traveling 12 meters per second left. After the collision, the first ball bounces left at 8 meters per second. Fine. And then we're given a whole bunch of information. So just quickly copy down mass 1, V1, because these are the things that you will need, as well as mass 2. And make sure you include directions. "12 meters per second left." And then not only that, but we will need the final velocities as well. So copy down V1 prime, as well as V2 prime, which is what we found. 1.5 meters per second left. Okay, there our data is, so we can go ahead and continue with the problem. So in order to determine if it is elastic or inelastic, you are going to find the kinetic energy before and the kinetic energy after and compare them. So let's start with EKI. At the beginning, you have the kinetic energy of object 1 and the kinetic energy of object 2. So adding both of those together gives you the sum. So note for questions like this, if you just put the EK formula up at the top to be 1/2 mv squared, you don't have to write it out every time. So 1/2 times the mass of 1 times the velocity of 1 initially Note that if the directions are different, so one's going to the right and one's going to the left, you're squaring them. So even if it's a negative number, it still comes out positive. So direction isn't as important here as it is everywhere else. Okay, 1/2 times 2 kilograms. So we're on to object 2. And times 12 meters per second. All right, type it into your calculator. I prefer to do it all in one step, and usually I just put the 1/2 in as 0.5 to save myself some time. Oh, and I forgot a square here. And I get my kinetic energy at the beginning to be equal to 171 joules. Now we check to see if that is equal to our EKF. So at the end of the system, we still have velocity of object 1 and velocity of object 2, which means that both of them have kinetic energy. So EK1 prime plus EK2 prime. All right, so 1/2 times the mass of 1 times the velocity, 8.0 meters per second, that it is moving after the collision. Plus that with the mass of the second object times the velocity of the second object. And then go ahead and type that in your calculator. So notice that in this case, once again, our EKI was greater than our EK, the sum of our EKF. Therefore, it's an inelastic collision. Okay, the next thing you need to do is copy down the information from example 5 onto this page. That's the one we're going to do next. I have copied down the information from example number 5. So I want you, this is 6.0 by the way, in case you can't read that. I want you to go ahead and try this question on your own, and then when you're ready, you can unpause the video to find the answer. So go ahead and pause. Here's the solution to the question. For the initial kinetic energy, you get 40,500 joules, and for the final kinetic energy, you also get 40,500 joules. Is what that tells us is that the initial is equal to the final. So this is our first example of an elastic collision. The kinetic energy has been conserved throughout the collision. So it's now your turn to practice. Go to your assignment booklet, the one that I passed out that has all the questions in it, and I want you, oopsies. So you can complete the energy in a collision worksheet that's located in the back of the worksheet package that I handed out. Make sure that you do those first before trying the questions in your formative assignment.